So to understand imaginary numbers, we kind of need something to go off of and a definition of what an imaginary number is. So the purpose of an imaginary number is to deal when we have square roots of negatives. So square root of -1 is defined to be I, imaginary number I. And so what should kind of make sense if you do I squared, if you think about that, I just wrote, square root of -1 is I. If we square both sides, if you square the square root of -1, you would just get -1. So that's kind of our two definitions of what defines what an imaginary number is. So let's use that to do some simplifying. Like if we had the square root of -9, this is, we could break this apart to be the square root of -1 times the square root of 9. The square root of -1 is I. The square root of 9 is 3, which we write that as 3I. We treat I just like it was an X. A lot of the rules we do, or the way we write it, we treat it kind of like it's an X, even though it represents I, an imaginary I, which is the square root of -1. So as we get better at these, we can just jump to write as the square root of -9 is 3I. But that's kind of the breakdown of why. How about the negative square root of -50? So this is negative square root of, now I'm going to break this down to -1 times what perfect square is in 50, 25 times 2. So I have that negative hanging out in front of there. The 25 is going to come out as a 5. Square root of -1 is going to come out as an I, and then we still have square root of 2. So that would be simplified as -5I square root of 2. Can't do anything else with that. Now, one rule that we usually use that is no longer going to work, and I'll say when A or B are less than 0, then square root of A times square root of B is not the square root of A times B. So that's that product rule of radicals that we've been using, but when A and B are less than 0, it doesn't work. So let's look at an example when. So if I had the square root of -3 times the square root of -5, normally we would say that that is the square root of +15, but not the case here. Because if I pull out an I, so if this was I square root of 3 times I square root of 5, okay, now I can make square root of 3 times square root of 5 square root of 15, because now the A and B are positive. But I'm still left with this I times I. I times I is I squared. What is I squared? -1. -1 square root of 15, which can be written just negative square root of 15. So basically, if we had just right away done -3 times -5, we would add a positive square root of 15 when this really should be a negative square root of 15. Let's do one more of these. How about square root of 27 times the square root of -3? So 27, there's a perfect root in there. That's 9 times 3, so this is 3 root 3 times, pull the negative out as an I. It's I root 3. So right now I have 3I root 9, which is 3. 3 times 3 is 9I. And I could have done that a few different ways. I could have done the 27 times 3 and then pulled out the I, but either way, I should end up with 9 and still an I there. Because notice there was just one negative in the root, in the square root, so we would end up with an I.